Hello, everyone, and welcome to our live webinar on what is data science and how to become a data scientist. My name is Rustam, and I'll be the moderator in today's event. Without further ado, let me pass the floor to our today's presenter, Professor Vadim Sokolov.
Good afternoon, guys. My name is Vadim Sokolov. I'm Professor at George Mason University. I'm researching data science, and I teach data science to engineering students. Before that, I was a lecturer at the University of Chicago, where I also taught data science in the master's program. And before then, I spent 9 years at Argonne National Lab as a computational scientist. And I also had a joint appointment at the University of Chicago. And my formal training is in computational mathematics. I got my PhD from Northern Illinois University. So we'll start with first question, what is data science? And I will talk about a few examples. One example from past, one example from the recent past, and one modern example to give you an idea how data science was done many years ago and what progress we've seen since then. So let's start with the 18th century. Data science is not a new field. Data science has been around for quite a while. It has been a field that was mostly studied by mathematicians. Here I give you a couple examples. Jacob Bernoulli published the first paper on analyzing distributions and random variables in 1685. And it's considered one of the first rigorous treatment of data analysis task. And nowadays, he's famous for what we call Bernoulli distribution. And even though this tool was invented in 1685, this tool is still an important part of a data analysis toolbox. Another example is a French mathematician, Simeon Poisson, who is in 1827, published his book on probability distributions and data analysis. He was famous for analyzing the trajectories of celestial bodies, of the planets. He used observations from the telescopes and was trying to use those to build mathematical models of the trajectories of the planets. So he was the first one to rigorously address the problem of solar mechanics, and he used data analysis techniques. And nowadays he's famous for what we call Poisson distribution. And again, it was invented in 1827, and this is a tool that's widely used nowadays. But let's look at a more concrete example. Let's look at this example that was discussed a lot in the 18th century. And the question was, does the Earth look more like a lemon or a grapefruit? So you can see two pictures. So the left picture is the lemon, and the right picture is the grapefruit. And there were two theories. French would say that it does look like a lemon. It looks like prolate, based on Cassini's survey data. And the English would say it's oblate. It looks like a grapefruit based on the Newton's gravitational theory. And there was a whole bunch of debates about the shape of the Earth before 1755, when Boskovic from Dubrovnik, which is nowadays Croatia, he is a scientist that used observations to answer this question that was so debated in the 18th century. So what he did, he took relationship between the latitude and the length of 1 degree of the Earth, and he measured it close to the equator. So Quinto is the town in Ecuador, which is close to equator, and Lapland is the town close to the North Pole. And then he tried to measure how the length of 1 degree arc changes from the pole to the equator. And what he found out, that at the equator, the length of one arc is smaller, meaning that the Earth does have a shape of a grapefruit. And he answered this question by collecting data and putting it on the plot. So it's probably was one of the first scatter plots used for data analysis. And the uptrend on the scatter plot says that it does look like a grapefruit. So scatter plot, again, one of those things that has been used many, many years ago. In this 18th century, people were using it. But modern data science still relies on scatter plots. And scatter plots is probably one of the most popular data analysis tools of nowadays. Let's look at the more recent example of data analysis. This is example from USS Scorpion search mission. USS Scorpion was a submarine. It's a nuclear submarine. It's an attack submarine that was on the mission to Azores Island, which is a Portuguese island in the Atlantic, to observe Soviet vessels. And on May 27, 1968, USS Scorpion was scheduled to come back to Norfolk, Virginia, its home base, and it did not show up. There was a whole bunch of people gathered on the dock. Kids and wives were waiting for the sailors to come back home, and it simply did not show up. And nobody knew where the Marine was. And the last time it was contacted was 6 days ago, and 2,600 miles earlier, near the Azores Island. So between Azores Island and Norfolk, Virginia, nobody knew what happened to the boat. And of course, a search was commissioned right away. There was a whole bunch of ships that were looking for it and airplanes. And for a few weeks, nobody could find anything. It's like looking for needle in a haystack. And Lyndon Johnson, who was the president at those times, he proclaimed, "We are all quite depressed. We have nothing that is encouraging to report." So it was an issue of a national scale. It was discussed in the media a lot, and it was pretty desperate situation. Before, John Craven and Larry Stone took the problem in their hands. So John Craven was a Marine, and he was a scientist. And Larry Stone was a Bayesian scientist. Those are two people who analyzed data side. But John Craven was more on the domain side. He understood the marine missions, and Larry Stone was a pure Bayesian scientist. So what they did, they used data from underwater microphones. Those system of microphones was installed again to monitor Soviet submarines. And they took measurements of strange sounds from those microphones, and they combined the measurements from microphones with the data they collected from experts. So they talked to a whole bunch of experts, and they asked what they think the cause for this marine to be missing can be. And they used Bayes' rule, which is one of the, again, most famous tools of data science even today. They used the Bayes' rule, the mathematical equation, to combine human intuition, experts' opinion, with the measured data from those underground sensors. And they predicted where the boat is going to be. And on October 28th of the same year, Scorpion was found 260 yards away from the location suggested by the model. So can you imagine, we're talking about huge, huge area covered by potential location of the missing boat. We're talking about 2,600 miles distance between Azores Island and Norfolk, Virginia. And the model predicted very accurately where this boat is going to be. And the most recent example of a data science, and it's an example where artificial intelligence and humans work together, is this company called Stitch Fix. So Stitch Fix uses data science for pretty much all of the operations of this company. They use optimization routines to optimally allocate products to the warehouses. They use optimization to optimally schedule the shipments. But most interestingly, they use data science to decide which clothes you're going to like. So the way it works, you go to the website, you fill in the form, you say who you are and what type of clothes you like, and you tell them your measurements, and then they will run machine learning algorithm on that data. And machine learning algorithm based on the predictions from the past and based on the opinion of their designers will suggest 5 items, and those 5 items will be shipped to you. And once you receive them, you will decide whether you like them or not. And if you don't, you send the items you don't like back. And then they run machine learning algorithm again. They retrain the machine learning algorithm. They say, oh, those are the items that were liked and those are the items that were not liked. And we update the machine learning algorithm. So next time, it gives a more accurate prediction of what people of your type would most likely prefer to wear. So this is a company that was founded in 2011, and as of February 2018, the company was valued at $2 billion with a B. And most of the value of this company comes from application of machine learning algorithms and data science algorithms to run business operations. Data science is a creative field, okay? So it's not like you have some off-the-shelf solutions that work. They usually don't work. Usually you have to be creative how you apply those tools that you have in your possession. You have to be creative of how you formulate the problem. Even formulating the problem is sometimes not the easy task. It takes a lot of discussions, it takes a lot of talks with the main experts, with people who understand the field in order to understand what kind of data analysis would benefit the business. And well-defined job roles on the data science job market are very uncommon, though they exist in larger companies. So conveyor belt approaches do not work. This is a picture you see in the right bottom corner of the slide. It's a conveyor belt at the fish processing factory where each person has a very well-defined sequence of steps that need to be made in order to process the fish. And basically, a fish goes from one person to another, and this person repetitively applies the same sequence of steps and again to each new fish. So those type of approaches do not work in data science. It's pretty much in any high-tech job. So you have to use your imagination. You have to be creative. You have to be able to talk to people. You have to try to find some discoveries through those processes. It's not mechanical process by any means. So let's talk about next question. Why should I care about data science? What's so special about it? Well, one thing is data science is very popular nowadays. And if you look at the plot, this is the plot from Google Trends. So Google Trends is a service that you can, it's a public service. You can go and use it yourself. Just go to Google Trends and you can specify search query. So what I did, I specified data science search query. And I looked at how many searches were incoming to Google for that specific keywords. And as you see, starting somewhere in 2014, you see an exponential growth in the data science search terms. So that basically shows you the interest from the general public on data science topic. But let's see it a little bit more concrete measurement of how popular data science is, and that's probably the metric that people who are on the job market for data science care about, is how many jobs there are. We know there is a hype around data science. We know there's a lot of news article, but the more important thing is there are data science jobs. And this is analysis did by Indeed. So Indeed has this hiring lab. It's basically a little R&D group inside Indeed that does all type of analysis based on the Indeed job postings. And if you're not familiar with Indeed, Indeed is a job posting aggregator. That's a company that collects job postings from different websites and puts them together in one place. So if you look at the analysis did by Indeed, what you will see on this graph is the proportion of the data science job per 1 million postings on Indeed. And again, you see this upward trend from December of 2016 to December of 2018. Within 2 years, the proportion went from somewhere in 600s to somewhere around 1,000. So we are talking about huge, huge growth in the job postings for the data science. And data science is popular not just because there are a lot of jobs, just demand on the job market is one component of that, but there are a few other components. One component is job satisfaction. People who do data science job do report to be very satisfied with their jobs. And another component is the salaries. Those jobs are pretty highly paid. And for that reason, Glassdoor named data science to be #1 best job in America for 2019. And by the way, data science appears in those top lists for quite a few years. And the first ones actually to identify the trend and label it was Harvard Business Review. They published an article in 2012 where they said that data scientist is the sexiest job of the 21st century. And those was the days, 2012 was the days when data science was not that popular, so it was still picking up, but they realized that and they had a huge article. So if you're interested in the history of the data science, that's a good article to read. And this is a little bit more recent title from January 17, 2019. Data science is a hot job that pays well, again, published by Indeed, where they provide a whole bunch of statistics about job market and how fast it's growing and what's the demand for those type of specialties. Geography matters on the job market. Those jobs usually concentrated in metropolitan areas, as if you would expect from any high-tech job. And one of the surprises for me when I looked at this Indeed article about the top cities for the data science jobs was that while New York and Silicon Valley was number one and number two, that was not a surprise. But Washington, D.C. basically follows the Silicon Valley and New York, and it's number three in this list. So Washington, D.C. has a huge demand for data scientists, and if you already live in this area, you most likely will be able to find jobs somewhere around and don't need to live anywhere. The next question is how to become a data scientist. So some of you might be on the path on the job market already, but some of you might be just at the stage where you try to figure out if that's something that you want to do or not. And so I will share some of my experience and some of my observations of what paths people used and what paths do work and that paths do not work. And my observations basically comes from communicating and talking to my students. I've taught data science to probably 200-300 students already, and I keep in touch with some of them. And most of them went through the job markets, and some of them already were on the other side when they are hiring other data scientists. So we'll try to think about the whole process, how do you become data scientists and how do you find a job on this market. So first thing you want to identify is who do you want to be. Data scientist is a very generic term, and there are a lot of different job titles that would describe a data scientist. So data analyst is probably one of the least technical ones. Data analysts usually would know some basics of statistics. They will know how to do simple operations with the data, but they have to be very good at understanding business needs. So they need to talk to people, they understand what type of data analysis might be beneficial for this company. And of course, they have to be able to communicate. They have to be able to present their results and explain their findings. Data engineer is slightly more technical. Data engineer is more of has a computer science flavor to it. It's data engineers are people who try to take whole bunch of servers and different software pieces, install them those servers, and then they write what is called the glue code, so some code that puts things together. So all of those servers and all of those pieces of software can work together and provide a pipeline for a data analyst who at the end of this pipeline will take something manageable that can be loaded on a laptop and work with it. So data engineers usually work with huge amounts of data where distributed computing is required, where you have to have multiple servers, and usually data is shared between those servers. And then you have to write code to orchestrate this data, combine this data together. So you need some programming skills, and you need to understand how cloud, for example, works. Machine learning engineer is another example of a technical title. And machine learning engineer would be expected to know cutting edge methods in machine learning, like deep learning. You would be expected to write your own code for data analysis, and you would be expected to know how data analysis algorithms work. So you need to know insights of those algorithms. Statistician is a more traditional title for data science. So data science of the last century, those are statisticians, most of them. And statisticians usually deal with uncertainty and hypothesis testing. And statisticians are very good in analyzing small amounts of data. They're very good in understanding how small amounts of data lead to uncertainty in the predictions. So statisticians is still a very relevant job. There is a huge demand for statisticians for more traditional data analysis techniques. And if you're a statistician, you should be able to find a job just fine. And data scientist title can really be given to any of those jobs above. So whenever you see machine learning engineer, it can be as well be called data scientist. So those things are more or less interchangeable. But again, if you look at the Google Trends, and if you look at how popular each of those terms are, so I try to compare data analysis, data science, business analytics, and data engineering. And looks like data science to be the most popular term on the Google searches, meaning that in the general public and probably in the companies that are trying to hire, this is the term that's used most widely. So my insight based on this silly Google trend analysis is that if you are to put a resume on LinkedIn, or if you are to submit a resume for a job, you probably will be safe calling yourself a data scientist. So if you're not sure where you are and not sure how to label yourself or what type of title to put in your resume, just put data scientist. It's most popular, and a lot of people will recognize this title. Okay. And Indeed also did analysis of types of skills that you need on the data science job market. So actually, and they also did analysis of so they did analysis of the skills, and what they found out that data scientist most likely will appear under the name machine learning engineer or data scientist. So again, on the job postings, those are the titles that used the most often and the most frequent. But again, machine learning engineer would usually have this little bit more technical flavor, and data scientist will have this flavor of more generalist. And as you see, statistician is also in this list. Statistician is number 8 on this list. So statistician title is a little bit less popular in the job postings compared to the machine learning and data scientist. So again, if you want to label yourself one way or another, even if you have statistics degree, it seems like calling yourself data scientist or machine learning engineer just by pure word matching or keyword matching, which is used by a lot of companies nowadays to filter out resumes, that's a good combination, data science and machine learning, to be used for your resume on the job market. And title of your job also will affect the pay. Again, if you look at the salaries for different titles, you'll see that data scientists and machine learning engineers, number 3 and 5 in the list, they're highly paid jobs, $134,000 on average. You have higher paid jobs, but those usually will have some title of principal or director, so those are more management jobs. So for entry-level position, we're talking about machine learning engineer and data scientists. But again, if you call yourself a statistician, which is number 9 in this list, then just purely by title, your salary will go from 130,000 to 83,000, even though statistician and data science might be doing exactly the same things. So again, if you want to call yourself, or if you want to search for job postings and put something on your resume, put data science, just because it's something that is more often used in the job postings, and apparently people are willing to pay higher salaries to data scientists compared to statisticians, even though it can be the same thing. All right, so what type of skills you want to learn if you want to become a data scientist? And usually 4 types of skill sets you will need to have. First is mathematics and statistics. So those are hard skills. You need to understand the math part of the data analysis. A lot of the data analysis happens through mathematical equations, and a lot of the data analysis algorithms require some knowledge of the math. Second skill is programming, because nobody uses Excel anymore. So you cannot just drag and drop things and do manipulations in Excel. So if you want to be serious about this profession, you got to learn how to program. Serious data analysis shops would use R or Python. Less often SAS or Stata will be used. So if you want to pick a language, R or Python would be a safe bet for you to program. You need to understand visualization techniques and data wrangling techniques, how to read data from file into memory, and how to plot results of your analysis. And another thing that is usually less obvious is the communication skills. And I've been teaching in university environments for the last 5 years. And this is one of those skills, for example, we do not teach at universities. We do not teach people how to communicate. And another thing you have to keep in mind is that although you need to know basics in communications and math and programming and data visualization, you probably want to pick one category and you want to excel in this category. And the reason you want to excel is that that's how you distinguish yourself on the job market. So if you're kind of okay in all 4 categories, it will be harder for you to find job than if you're kind of okay in 3 categories and really good in 1 category. And usually the hiring process will go in the following way. For example, company has a certain set of tasks of data analysis that need to be done, and they will try to hire 2 or 3 data scientists with complementary skill so that the overall profile of the team will allow to finish the data analysis job that company has. So what you see example here on the left, you have an individual profile of a data scientist. So this specific data scientist knows statistics rather well, but not very good in communications, for example. And then she gets combined with 2 other data scientists. So one of them is very good in the domain expertise, and another one is very good in the communication. And when you combine all of those skills together, you have a team of data scientists that has very rounded profile of the skills. So if you kind of okay in all of those categories, then it will be hard for you to find a job. That's the bottom line. Okay. And there's a whole bunch of those matrices that try to match skills to data titles. I like the one that comes from Udacity that fits my personal observations of how data skills and titles match to each other. So if you want to, for example, become a data analyst, you do need to know a little bit of programming. You do need to know a little bit of optimization of visualization, but you don't necessarily need to know machine learning, and you don't necessarily need to know statistics. You need to know simple tools from statistics, how to calculate means and standard deviations, and maybe how to compute simple models like linear models, but you don't need to know much more advanced techniques than that. Okay. Another thing to keep in mind, if you are already a data scientist or you are preparing to become a data scientist, is that tools do change over time, and you'll have to learn those tools. So this is one of the examples. Again, I used Google Trends to compare linear regression and deep learning. So deep linear regression is the technique that data scientists have been using over the last 300 years. It's a very well-known tool, and it's still relevant nowadays. And deep learning is something new. Deep learning is something that became popular in 2012. And you can see that if you look at 2014, somewhere in 2014, the deep learning was not a very popular search topic in Google, but by March 10 of 2019, it's actually as popular as linear regression, which means that if you're a data scientist who've been on the job, for example, for the last few years, you probably want to invest your time and you want to learn deep learning. And even if you're a beginning data scientist, if you're a person who are thinking of becoming data scientist, you do want to invest your time and you do want to learn those new tools that are currently in high demand on the job market. But some knowledge does not get obsolete. So this is a quote from Donahue's paper, 50 Years of Data Science, who says that hiring organizations face difficulties making use of the specific information technology skills being taught in degree programs. In contrast, data analysis and statistics are broadly applicable skills that are portable from organization to organization. So the bottom line from his analysis is that mathematical skills, they do transfer, but knowledge of specific programming languages, of knowledge of specific libraries for data analysis are not necessarily going to be transferable from one company to another, and that's something you will have to learn on the job. So the bottom line is invest your time into learning basics, know your math very well, and this is something that will carry through the entire career in data science for you. And another point is that soft skills do matter. Don't underestimate how important it is. Here's a quote from an interview with Chairman Dustin, who says that the number one thing that I look for is curiosity. And another observation was done as a result of a poll that was run on Twitter. A whole bunch of data scientists were asked the question, what is the most important attribute you look for when hiring for a data scientist? And the most popular answer, to my surprise, was that problem-solving curiosity. And the second most popular was communication skills. So when I saw the question, I thought the most popular answer will be math. Well, I'm a mathematician by training, so I might be a little bit biased, but it seemed quite obvious to me that math is going to be number one. But apparently not. A whole bunch of people who do hire on the data science job market, they think the communication and curiosity are the most important ones. Another question I get asked a lot by my students is how much theory do I need to know? And my answer is not much. So don't get overwhelmed with theory. Don't get frustrated if you don't understand the theory. That's just fine. And again, this is another quote from Bill Cleveland. Bill Cleveland is the data science himself. He's a Purdue computer science professor who actually coined term data science in 2001. So he says that data science should be judged by the extent to which they enable the analyst to learn from data. So tools are relevant and theories are irrelevant. And Bill actually suggests his own list of skills that data scientists should possess, and he actually assigned shares to those skills. And I did my own little version of this tool set that data scientists, I think, should possess. I categorized in three columns: theory and models. So this is your math and statistics. You need to know descriptive statistics and data visualization. So this is a must. And as more advanced topics, you want to invest your time into learning linear algebra, random variables, and calculus. On the programming and computer science side, you do want to know data manipulations and wrangling and how to visualize data sets. So it's basically how to program the types of plots that you want to retrieve from your data. And as advanced skills, you do want to know Linux and how to do shell programming. You do want to know SQL, machine learning packages, and Hadoop ecosystems for large-scale data sets. On the communication side, which I assigned 40%, and this is consistent with what Bill had suggested in his paper, is that you do want to have listening skill. You do want to be able to listen what domain experts tell you, what they think the problem is. You have to be able to understand this problem. And for you to understand this problem, you need to learn a little bit about domain. So if you work in the marketing and your main job is to understand the effectiveness of marketing campaigns, you do want to understand a little bit about marketing. So ability to learn quickly the domain and the specifics of the domain is important for a data scientist. And of course, you want to be able to communicate the results. At the end of each data analysis job or project, you usually will go back and you will report to domain experts, and usually you will report to people who higher ups, to VPs or directors of the company. So people with MBA degrees, which might not even be familiar with Excel. So those people have no idea what data science is and what techniques you use, but you should be able to communicate those results to those people. Okay. So another piece of advice, again, I talked about this before. You want to become good in one thing. You have to pick one thing, you have to specialize it. And this one thing can be specific machine learning technique like deep learning or interactive visualization, or it can be a domain, for example. You want to become a specialist in geospatial analysis and you want to specialize in that. And then you occupy this niche, and if you're good at this niche, you're more likely to find high quality jobs than again if you're like okay in all of those categories. Okay. So next question, I'm a beginner, where to start? First generation of data scientists were predominantly physics, math, and computer science PhDs, and I belong to this group of people. But things are different now. So we have a whole bunch of master's programs in analytics run by universities. We have boot camps, and we have on-the-job training. Some companies have formal training procedures. Some companies have informal, and self-taught is another route. There is no licensing required for data science. And frankly speaking, degrees become more and more irrelevant on the job market. 99% of the interviews on the data science job market will be technical interviews, meaning what people look at, they're not going to look at your GPA, they're not going to look at your fancy diplomas, but they will care a lot about your technical skills. They'll care about how you solve the problems, what tool you solve the problem, how you communicate results of your solution, and how can you deal with other people. So those skills are usually more important than training skills. And your path to becoming a data scientist is very individual. It's very, very hard to give a very generic advice. It depends on how comfortable you are with math, how comfortable with programming. Did you do data analysis before in Excel or Tableau? So it's very individual. And what I suggest that you try not to find some generic solution online. You should try to talk to somebody who knows data science, and you can explain your context to him and try to get advice from a more experienced person about what will be the best path for you. Be aware that learning on yourself is hard. So this is a quote from Mindshift book by Barbara Oakley. She teaches this online courses to millions of students, and her observation is that only 5 to 10% of the students can self-educate themselves. So if you try yourself, you go online, you take online courses, so you try to pick a book and read yourself, and you do not succeed, that's fine. A lot of people actually do not succeed, and only 5 to 10% of people do succeed. So I would suggest, if you try to teach yourself and you try to avoid formal programs or boot camps, that you build a support community. So try to find a peer at work or at school, a friend who you can work with, and then you can pick an online course or pick a book to read and just go through it together. And going through it together does help a lot, and it does increase percent of success for you. And if you want to do self-learning, you have to understand it's hard. It might get overwhelming and you might get demotivated. A lot of people do. So what you should do, you should try to concentrate on a very limited set of skills. You pick one programming language. Don't try to learn two programming languages at the same time. Pick one problem, learn tools that are required to solve this problem, solve it. All right. So, and this is some of the advices for looking for a job. So if you are a person who is ready to go on the job market, then you definitely should build a portfolio. Take a project, beat it to death, write a blog on this project, explain how you solve the problem. Videos or interactive graphics does help. Look for good examples of how to present your findings at New York Times or 538.com. 538 to me is a golden standard of how data science results should be communicated to others. Even if it's an old problem, you might try to get some new insights or have some interesting perspective based on your data analysis. Publish your code and show your coding skills, and don't get intimidated by job listings. Many places don't know what they want, and they put every single keyword into the job ad. And it has been my observation, and it has been another observation of the more formal analysis. It's the paper called Analyze by Analyzers. They say, despite the excitement around data science, the ambiguity of these terms lead to poor communication between data scientists who seek their help. So people who hire data scientists very often don't know what they're hiring for and whom they want to hire. So this is a list of references of some materials that I used for this presentation. We'll publish the slides. So if you wanted to read further, you will have those links. Here's my little summary of the presentation. Data science is growing and it's here to stay. Many industries just started exploring how to use their data. There is a shortage of data scientists, so there's a big demand on the job market. And there are many paths from self-taught to PhD in stats with masters in analytics or boot camps in between. So you have to choose. You have a lot of options of how to become a data scientist. And the least is that if there is a will, there is a way. So if you want to become a data scientist, there are a lot of opportunities on the job market and on the training side of how to become a data scientist. So if you're really passionate about this field, it's a good way to come in and study that. And I will finish saying a few words about the Nova Data School. It's a new venture. That's something that we have started a couple months ago, and we will start running a bootcamp. It's going to be 12-week on-the-ground bootcamp in downtown Fairfax. Will be taught by 3 people, myself, Jamie Wheeler, who is a senior lead technologist at Booz Allen, and Bhakti Husseinov, who is a solution architect at Proficient. Bhakti will be teaching Big Data, Ecosystem, Cloud. Jamie will be teaching leadership in communications, and I'll be teaching stats and computing. It will be part-time on the weekends and evenings, and we will teach a full data lifecycle from collection to presentation, and we will provide individual career services support. And if you would like to know more, please contact us at info@novadataschool.com. Thank you very much. All right, so let's look at the questions. We'll go through Q&A section. Can someone without technical background pursue a data science career? I've seen a lot of people without technical background pursuing data science career. Again, as I said, I taught data science to a few hundred students already, and probably 10% of them are people without any technical background. So typical backgrounds, you would see people with engineering degrees, people with econ degrees, But I did teach people with English degrees and with history degrees, and they did just fine. So the only thing you have to keep in mind is that if you have non-technical degree, it will just be much more work for you, and it's to become a data scientist. So it's more uphill battle. You have to invest more time into it and more dedication, but it's doable by all means. Okay. Which programming language is more popular, R or Python? If you have asked me this question 5 to 8 years ago, I would say R. And I'm a person who prefers R, for example, till nowadays. But if you do analysis of job postings for data science today, you will see that Python is a more popular one. There are more job postings for data science that ask you to know Python than R. So to me, it seems like Python is taking over slowly. But if you continue this trend, I would say in 5 years, Python will dominate by all means. All right, so it looks like there is no more questions, which means that it completes our webinar. Thank you very much to those who participated.
Thanks a lot, Vadim. And we will be extending the invitation, which is exclusive to the participants of this event, to attend our on-campus program overview. You will also receive the recording of this event in your email. So be on the lookout for a couple of emails coming your way over from the Nova Data Science. It was a pleasure to having you. Thanks, Vadim, for this great presentation. And stay in touch. You can always contact us at info@novadataschool.com or call us at 571-512-5152. Have a great evening, guys. Bye.